Factoring in applications lesson 4. We're going to be factoring, looks like, difference of squares. These ones here you've seen already. These ones here. This just means that the coefficient's going to be a square. And these ones here is where you would want to make a substitution. So when they give you some complex function, or pardon me, not complex, but like something that's difficult, and you have to square it. So we're going to just make a substitution here. Okay? And you'd make the same substitution over there. So you'd probably go something like this. Let a equal f of x. And then once you've done that, you factor it with just the symbol a, and then you're good to go. And I don't need to do this. You guys should know this by now. But if you were to FOIL all this out, the middle term disappears, right? So just put that there. The middle term cancels. And that's why these should look like trinomials, but in this case, the trinomial, if you were to write the trinomial like this, ax squared plus bx plus c, this guy goes away. It cancels, so it's not there. And then this will end up being a square. So, nevertheless, let's just try one of these. So when we have difference of squares, we just open up a couple brackets. One's going to be plus, the other is going to be minus. These are very easy. You just need to spot the symbols. If you see 9 and 16, you're like, okay, yeah, probably got some squares going on. Okay, so we always need to square root each term. 3x, 3x, and then 4y, 4y. That is a Math 10 style question, just to refresh your minds. Any questions about that? Let's just FOIL this in our heads. 3 by 3 gives us our 9x squared. Let's do the inside and the outside. Minus 12xy and plus 12xy. Those go together and cancel out. And then the last is 4 by 4 giving this 16y squared. And the positive and the negative make this. That's why we do difference of squares, right? Positive times negative. Okay. Okay, so 3 and 27, they're not squares, right? First thing on the flowchart. Right? First thing on the flowchart. So you go take out a 3 and x and y. You end up with x squared minus 9y squared. Do you agree? Bring the GCF with you. This is another difference of squares. Break it down. X and x. Do you agree? Okay, plus, minus. Now think about the root of 9. 3y and 3y. Can we keep going on that? We're done, right? Over this one here. 144 is a perfect square. So is 4. Just quickly double check if 144 divides by 4 though. It does? Because it ends in a 4, right? So that's a divisibility rule. Good. Divide out of 4. You get 36. P squared Q squared minus R squared. Is there a difference of squares in the bracket? Because 36 would go to 6, and then PQ. And that's what I like to do. I like to put the structure in and then fill in the space, because then I don't have to think about it. So now I'm like, okay, how to make an R square? So it has to be R and R, 1's plus, 1's minus. Questions on that? Okay, now we have this word problem. Says a pane of rectangular glass gives you an area. Okay, so this happens all the time. I'm just going to jot a little note here. length times the width obviously fills the area. Okay. Now if you look above here, let's take a look at this one here. Do you see how it's a term times another term? You can think of that as like a length times a width. And then this stuff up here would be the area inside as a sum versus if you wrote it as a product. Okay? So if we were to factor that thing up there, area equals, I'm just going to rewrite it. Oh my gosh. Just going to rewrite it. And then I'm going to factor it. 7 for sure. 7x. And then the other one will be 4y. Good. One's plus, one's minus. And you can think of these as like a length times a width. Okay, so it told us that. It says the length and the width can both be written in the form ax plus by. We've done that here. You can see a is 7, b is 4. Determine the appropriate values for a and b, and hence write expressions in x and y for the length and width of the plane, or of the pane. We've done that. That's a check mark. Whoops. Okay. Now, let's do part B now. Given that the length is double the width, I'm just going to highlight that. L is, so L equals double the width, so 2W. You guys okay with that? Okay, so then 7x plus 4y equals 2 times 7x minus 4y. Okay, now it says the perimeter is 56. What's perimeter for a rectangle? 2 lengths plus 2 widths. So 56 equals 2 lengths, which is 7x plus 4y. And whoops. And 2 widths, so 2 times 7x minus 4y. Develop a strategy for determining the length and the width of the pane. So what they mean by this strategy for the length and the width is quite simply two unknowns, that's your x and your y, with two equations What does that mean you have to do? Last unit of Math 10. Rhymes with... I don't got no rhyme for it. System. What kind of an S is that? System. System of equations. You guys okay with that? Okay, can somebody read those out to me again? I'll just copy. I just need more space, that's all. So we had 7x plus 4y equals 7x minus 4y. And over here we had 56 equals okay, so with these two equations involving x and y, you have to simplify them and then line them up in columns and then do elimination. You guys remember all that? So let's simplify this left one. Got a 14x minus 8y. Dump everything to one side so that you just have 0 on the right. So you'd have 7x minus 14x, 4y plus 8y. You end up with minus 7x plus 12y. Okay with that? I'm just putting all the terms on one side, and then once that happens, I'll be able to stack the equations in columns and then add the two equations to make one of the terms disappear. Now over on the other equation we have 14x plus 8y, 14x minus 8y. So we got 28x. Oh, and the 8's cancel. See how lucky that is? I don't even need to do a system. I just need to find x. Is that 2? So once I got that, then I'm good to go. And that's a minus 14. Take that 14 to the other side, and I get 14/12, which is 7/6, which is like it's 1 1/6, which is like 1.16 repeating. Okay, so we have our values for x and y. We'll just use the improper. Okay, so do you guys still need a copy? Any questions about this? I got lucky in the system, because this system, the y's just disappeared, so I knew exactly what x was, and then once you know what x is, then it's quite simple to get y. So I wouldn't go with the mixed or the decimal. I would keep the improper. That's way better for them. And no question? You got a question? You only use a system if you have two sets of information and two variables, so that you can, with the two sets of information, you get two equations, and then you get two answers. One equation, one unknown, you're good. Two equations, two unknowns, you're good. If you have less equations than the unknowns, then it won't work out. Like if you had two equations but like 5 unknowns, you can't do it. Well, you can't do it precisely anyway. Okay, so let's go back. Now we need to actually determine the length and the width. So 7x was 2 plus 4, y was 7/6. You guys. 14 plus 28/6. What's 28/6? 6 goes into 24. 28/6 would be 4 2/3. So it's 18 2/3. And then the other one, it's 14 again, but this time we minus 4 7/6. So you get, was it 14 minus 4 2/3? 14 minus 4 2/3. And you know I can't subtract, so what's this going to be, like 9 and... Help me. 9 1/3? 9 1/3? Okay, good. You hate that, eh? So much? Why? Because there's fractions involved? Substitutions, there's eliminations, yeah. Yeah, but this is dash 1. That's all I gotta say about that. That's not hard. And you have to stay organized, and you have to know how to factor, and it's long. I used to do questions in university. It would take me like an hour to do one question, and it'd be like 3 pages. This is life. Now I get to be a teacher. Good times, right? This is only part B. Oh, you guys are lucky. Okay, now this stuff, that word problem, like whatever, okay, you guys? This stuff, more important, obviously. Now we have to try this difference of squares where there's a function involved, and we're going to use a substitution for that function. I wouldn't even do a substitution on this. I would do a substitution down here. These ones up here, if it's a monomial, I wouldn't substitute. See that? I wouldn't substitute. Binomial though, for sure I would. So let's think about squares. Squares for variables. Is x a square? No, x is the length. Is x squared a square? Yes. Okay, is x cubed a square? No, is x4 a square? Because you could go 2 by 2, right? So is x5 a square? x6? Yeah, so it's all the even ones. All the even powers, you can do squares. Okay, so if you see like this 5 right here, not a square. But there's another p over here, so you could probably factor out p. So we'll get there. So k4, is that a perfect square? Okay, so let's break it down. K squared minus 1, k squared plus 1. Am I done? So keep going. You got a k plus 1, and you got a k minus 1, and then you got a k squared plus 1. Because this is difference of squares. Breaks down further. Because it's a sum of squares. Positive. Can't do sums of squares. Okay, over on the next one. Good. I was just going to say that. Don't just jump into trying to do difference of squares with 80 and 5 because, well, 5 and 80 are not perfect squares. But they are both divisible by 5. And there's no variables in common, so we just have to divide by 5. It's 16a4 minus x4. In the brackets there, is that a perfect square? Or, pardon me, a difference of squares? The answer is yes. Bring the GCF along for the ride. You have 4a2 minus x2, 4a2 plus x2. Am I done? Keep going, right? On which one? The first one. So you have a 2a minus x, 2a plus x. And then that last one you have to leave because it's a sum. So we don't touch the sums. Okay. Daoud, what do I do starting off on this one? GCF, what is it? 2 for sure, and the P has shared, the Q is not shared, and the T is not shared. So taking out 2P, you get P4Q4 minus 81 T4. Too bad there wasn't like a R2 and a D2 or something. Come on. That would be wicked, right? Pardon me? Okay, so P2Q2 minus 9T2. Oh, T2? Get down. Come with me if you want to live. Right? T2? Come on, best movie ever made. P2Q2 plus 9 Terminator 2. Can I keep going on the first one? Oh my gosh, right? Okay, so what's it going to be? PQ minus 3T, PQ plus 3T. Good. And then copy down the last one. Good. Well, write it in there somewhere. It's definitely not hard. It's definitely time consuming, yep. And it's like, if you try to relate this to sports, it would be like, you can't really teach people to like work really hard in the moment or like have desire, but you can teach somebody to like do a jump shot properly, like you can, or a foul shot you can show them the technique. This is more about technique, so there's not a lot of like intuition or cleverness to it. It's mostly just technique, and can you remember how things factor. It's just a skill in your algebraic toolbox. That's all it is. Beautiful. Yeah, because if you want to take calculus, you have to know how to factor. And that's basically, this is a pre-calculus course, and you have to know how to factor. So when there's binomials involved, I'll probably just do a substitution. So for this first one, I would let that b minus c binomial be x. X looks good. So you have a squared minus x squared. That's superbly easy to factor. You get a minus x and a plus x. And then a is what it is, so we just need to subtract the substitution. And notice what I do there with the substitution. Whenever I have to substitute, I'm just going to use a bracket and then think about what goes in there. So what goes in there is a b minus c. I'll highlight that for you so you can see it. And then further simplification always. So this minus is going to come inside, and what's going to happen? Minus b and then a plus c. That's so critical. A lot of students will screw that up. A plus a b minus a c, because when you distribute a positive 1, nothing will change. So there's your final answer. Now for this other one, there's two separate binomials. So let's call this one capital A, and let's call this one capital B. And then you just have capital A squared minus capital B squared, which is just, whoa, what is that thing? We got an A plus a B, and we have an A minus a B. Now let's just sub in using brackets. And don't be afraid of these nested brackets. That's okay. So bracket and then bracket 2x minus y plus x plus y bracket bracket times in between bracket bracket. Okay, 2x minus y minus, running out of space here, minus x plus y bracket bracket. So we have an a plus b, we have an a plus b. We have an a minus a b, we have an a minus a b. Now we can go into further simplifications. 2x and x make, and a minus y and a plus y go away. A 2x and then a minus x gives us 1x, and then a minus y gives us a minus 2y. Okay, this one's way harder than this one because this is a plus, this is a minus. Minus outside of a bracket, you need to distribute in that minus. 2x minus 1x, 1x. Minus y, minus 2y. I always repeat that stuff in my head when I'm doing integer stuff. And never, 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 never do this. Don't redistribute, because that's undoing your factoring. So never redistribute. Okay, it's 10 after 1. Oh, there's one more. Woo! That makes you excited, right?
Only you.
You guys should be excited when you see math. Shayla's excited. Cole's excited. No. Fred's excited. Chi-Ming, you excited? You excited? You excited? Yeah, that's what I'm talking about. Okay, one more, you guys. One more. Okay, what do you see? All I see is 36y squared minus 49z squared. That's what I see. YZ? Because x, y, z, baby. X plus 5 equals y. X minus 8 equals z. What's cringeworthy? I'm cringeworthy? Slightly? Okay. Can we make that my Halloween costume this year? I changed my mind. Cringeworthy? What's something that... We have to come up with something. You want me to come to school with a big black trench coat giving kids suckers? That would be pretty weird. Oh, really? Nah, we gotta think of something better than that. Okay, let's go here. 6y minus 7z. 6y plus 7z. Resub back in. We got 6x plus 5 minus 7x minus 8. 6x plus 5 plus 7x minus 8. Any issues with that? Now we're going to have to distribute in and simplify. We have a 6x plus 30. We have a minus 7x plus 56. Let's just quickly simplify this again. Negative x plus 86. There's that first one. Over here we have a 6x plus 30 and a 7x minus 56 for a 13x minus 26. Because I hate subtracting. And then just make it a little bit cuter. I'm going to factor out a negative on this. I get x minus 86, because I just don't like my lead coefficients to be negative. And then I'm going to factor out a 13 on that, and I get x minus 2. Clean it up one more last time. Negative 13, x minus 86, x minus 2, and that's your final answer. So much factoring, right? All right. You got about 13 or so minutes till the bell. Good luck with your factoring.